Here's part 2 of Pre-Calc 10.1.3. It's hyperbolas. And so if we would have been in class together, I would have had a choice of either having you create one with a straight edge and a compass, or I could have had you do some like a derivation of it with algebra. There's plenty of videos on the internet that do both of those. I liked the compass one a little bit. I started it and then it would be too long of a video. So I think what I'm going to do is just try to convince you that if you remember the little string demonstration that I did, it's kind of the same thing. This distance, take away this distance, ends up being 2a. And I think, let's see, how can I explain that? Let's let this from here to here. So basically I'm going to say D1 is a longer distance and D2 is a shorter distance. So if I start from this foci and I let this be D1 right here, that'd be the longer one. And then this one could be D2. And I'm trying to convince you that D1 take away D2 is 2a. So now from here to here is, oh, I see how I can do it. Okay, here's how I can convince you. From here to here is 2a, right? Because from there to there is a, and from there to there is a. Like that's a, and that's a. So from here to here is 2a, right? See this little piece right here? Isn't that the same length as this little piece right here? So if I start here, I take this whole thing, and then I subtract this off of it, which is the same as this piece, then don't I just get this middle piece 2a? I don't know if that's a convincing enough argument for you, though. But it is true that D1 minus D2 is always going to end up being 2a. And it is also true, well, here, let's talk about eccentricity now. Wait, no, let's not talk about, let's look at all the pieces of, let's look at this diagram, and then I'll talk about eccentricity. So I tried to mention this in the last video. Basically, all your hyperbolas are going to have a center, and then they're going to have this distance right here. It's called A, right, from there to there. And then this distance from here to here is called B. And the distance, this little bitty this distance from the center all the way to the focus, that's called C. Okay, and then there's some other things that you need to know. There's these vertices, the foci, there's a center, there's these asymptotes that we use on this box. Well, the asymptotes that we use to help us graph, they're actual asymptotes of the graph. And then there's what on an ellipse, what we call a major axis. On a hyperbola, we call it the transverse axis. So the longer axis, or the axis that has the foci and the vertices on it, that is a transverse axis. And then the conjugate axis, I shouldn't say the longer axis, just the axis that has the vertices and the foci on it are called the transverse axis, and the other axis is called the conjugate axis. Okay, so now I'm going to talk about eccentricity, I think. Eccentricity, we talked about that in our in our ellipse. It was describing how round it is. So in a hyperbola, it's also describing something like that, but it's kind of like how curvy it is. So, well, this says, look at all the hyperbolas created. Well, you haven't seen that many yet, but all the hyperbolas you've seen so far. Similar to an ellipse, part of this difference can be described by the eccentricity. Recall that eccentricity can be calculated with this formula, E equals C over A, where C is the distance from the center to the focus. In the case of a hyperbola, C squared equals A squared plus B squared. And so I don't know if I need to prove that to you or not, but C is the distance from the center to the focus. But it also, if I scoot it up, it also is the distance from the center to the corner of the little box that you draw when you're trying to graph. And so if this is A, and then remember this part of the box is B, so that would be B, you can see that A squared plus B squared is C squared. So with eccentricity, C over A is always going to be larger than 1 because C is a hypotenuse. It's bigger than A. So that would make the eccentricity of these hyperbolas always greater than 1. So sometimes I don't even know if they're going to ask you for the eccentricity very often of a hyperbola, but now you know. And also this is very handy because this will help you find where the foci are, because C is the distance from the center to the foci, so you'll need to use this all the time. Remember on an ellipse, it's A squared minus B squared, but on a hyperbola, it's A squared plus B squared. Okay, so we're going to do 10-46 before we run out of time. It says, consider this equation. Use your results from problem 10-44 to help you sketch a graph, and then label the vertices and locate the focal point. So we're just going to make sure we know how to do these kinds of things. So to graph it, we're just going to look for the center. I don't have a minus h or x minus h, y minus k. H and k are just 0, so it's going to be located, the center's at the origin. This 9 tells me it's underneath the x, so it tells me go square root of 9 is 3. 3 to the right, 3 to the left to start making my box. And then this tells me go 4 up and 4 down because the square root of 16 is 4. So I made my little box. Then I connect the corners of the box. I draw these diagonals, and that gives me some asymptotes, and then I just draw in the nicest I can. I draw in my hyperbola, and there's its vertices right there. Okay, so this thing is the transverse axis. Now, my vertices, it's easy to see. They're just wherever that box that I drew. When I looked right here, I just was able to draw the box. So here's the vertices. So that was, oh, well, I got the problem wrong. It's 3. It was negative 3. There we go. Right? And then the foci, how can I find those? Well, I did that thing about c squared equals a squared plus b squared. So this is a squared and b squared. So 9 plus 16 is 25. So c must be 5. So that's where I got the foci. And then what else do I need to say? How would the graph be different if it was y squared over 16 minus x squared over 9? So whichever one is the positive one, or, like this minus sign is making this part negative, but this part's the positive part of the hyperbola, so this part is the one that's going to actually have the foci and the vertices on its axis, if that makes any sense. This one's going to open up and down. Okay, so if y comes first, it's going to open down, and if x open up and down, and if x comes first, it's going to open right and left. Okay, and that's because there would be no x-intercepts, because if I were to plug in a 0 for y, then I would get negative x squared over 9 equals 1, and multiply both sides by negative 9, x squared equals negative 9. That doesn't work. So that's another algebraic way of finding out that I wouldn't be able to get any x-intercepts. Okay, so that's just a little introduction for you. Ask questions in class. I noticed there's a math notes box for you. So go over those, see if you can figure this out, and we'll talk